Hello everyone, how are you? I hope you have liked the serverless series. Let me know in the comment section how you felt about it. Today, we are going to start a mini series of event driven architecture. So, what is an event? An event is a change in state or an update, like an item being placed in a shopping cart on an e commerce website. Events can either carry the state, the item purchased, or its price, or a delivery address, or events can be identifiers, a notification that an order has been shipped. This event has a capability to trigger further operations, like for example, S3 event notification. AWS have various event-driven services like Lambda, SQS, SNS, Kinesis, Event Bridge. Everything has a similar purpose to trigger or process event further. The data consists in an event is very important. Sometimes we need to process the data and sometimes we don't. So we have to identify a mechanism by which we can detect the event, inspect the data inside of the event, if required process further the event data and trigger other services. In this video, we have used AWS Lambda, Kinesis data streams to process and analyze event. I hope you will like this video. If you are new to this channel, kindly subscribe to my channel, give your comment, like, share. Also, if you have any other thoughts, please also mention that in the comment section. If you want to learn anything else, please also mention in the comment section. So let's go and start our event-driven architecture.
Now let's talk about event-driven architecture in details in this tutorial. In this example, let's say S3 got one event. Which event? It got object put event. That means suppose someone or some process, maybe an automated one or a manual one, put an object into our S3 bucket, and that object contains any operational data. So this is a triggered event happened in S3, and S3 has a mechanism to detect and respond to this particular event. Mostly S3 trigger other AWS services as soon as the detection of the event takes place. And in our case, we will trigger one Lambda function. So it will trigger one Lambda function after it got the event. So what this Lambda function will do? This Lambda function will parse the event coming from the S3 and show it into a human readable format. There are other use cases for Lambda exists as well. One of the use case, apart from showing us the event, we will use this to insert the same into one of the database. So which database? In our case, we will use DynamoDB. DynamoDB is a serverless feature of keeping data and it can scale automatically. So till now, we have seen one operational event which came into our S3 bucket, triggered a Lambda, and that in turn inserted the data into DynamoDB table. We still have something left in this example, which is, so after the event comes into our DynamoDB table, we will trigger one Kinesis data stream to stream the data into Kinesis. Those who don't know what Kinesis is, let me explain in short. Amazon Kinesis is an Amazon Web Service designed to process large scale of data streams from multitude of services in real time. So please remember, in real time. It can be considered like Apache Kafka as kind of message broker. This means that it operates as a middleman between various data generating sources to allow other applications or services to work with the source data. So the question might rise, if Kinesis can process the data from source, why can we not trigger it directly from S3? Why do we need Lambda in between? Well, there is some limitation of S3 sending event notification to services like only to Lambda, SQS and SNS. Also, sometimes the data needs processing in between, as we don't want to send all the data that is coming from source and send it to destination. Sometimes it needs some filtration. So in a nutshell, a S3 event which triggered a Lambda function, which again triggered DynamoDB insert, and which in turn triggered a Kinesis data stream is our purpose of discussion. We will set up everything from scratch and we will see everything is in action. So let's go and do the practical. So I am inside this AWS console and I am using North Virginia region. What we will do is we will first create an S3 bucket for this architecture diagram, and let's go to then S3 and create a bucket and give the bucket name as event source. This is fine, and I will not change anything, only the tag, and then create bucket. So I hope the name will be available. Yeah, so this is fine. So what we have done, we have created one bucket. The bucket name is event source beyond the cloud. Now within this bucket, we see that there are currently no objects, and we go to properties here and we come down and we see that currently there is no event notification configured. That's fine. This is what we want. Now our S3 bucket is there, and now we need one Lambda. So the Lambda we have to create now. We go again here, our management console, and we open up Lambda. We create one function and give the function a name called parse event, and this function we will do it with Python 3.9, and I will not change any permission here. I will use the default permission, and then we will create the function. Do remember to give this particular function a role. We go to configuration first, and first of all let's edit the timeout setting. So maybe I will give it a 5 minute. 5 minutes is enough for us. Okay, and this is the role, so I will open this role and then I will save. Okay, now my timeout has been modified and we have to give the Lambda proper permission, what permission it needs. So eventually the Lambda will parse the event from S3 and it will insert into DynamoDB table. So the main permission it needs is the DynamoDB permission. What we will do, or what I will do here to make it very simple, I will attach the admin permission to this Lambda, but don't ever in production attach this admin permission to Lambda. Rather than sort it out, view the CloudTrail logs, what this Lambda calls, and according to that give the permission, create an custom inline policy and give it to Lambda. Don't give administrative access to any Lambda to your permission. So my Lambda permission is given. I will refresh this Lambda, and if I go to configuration, I see permissions, I see all actions is there. So but this is for demo purpose. Don't ever give all permission to Lambda again. This is fine. I will close this IAM section, and again if I go back, now my S3 bucket is there, my Lambda is there. What we need one event. So, and apart from that, we need to parse the event, or we need to show the event, what the event came in. So if we see the Lambda code here, so Lambda have a parameter called event. This is the particular event that we are interested in. So whenever S3 will trigger event to Lambda, this is the variable that holds all the data. What we will do to make it simple, we will print the event and we will deploy. So first of all, there will be no CloudWatch logs created. If we go to monitoring, view CloudWatch log, I don't think any CloudWatch log will be created right now because the Lambda is not triggered. We see that log group does not exist. What we can do now, in S3, we create this event. How do we create this event? So in my desktop, I have a JSON file, and the JSON file I have is this one. So in this JSON file, this is very simple one where we have a float called apple, size, the apple size is large, and color of the apple is red. So this is a very simple JSON file. So this we will upload to S3. This is an event. So whenever we will upload this file to S3, this is a put object event, and that put object event should call our Lambda function. So that we need to configure now. To configure that, we need to go to properties. We need to go to event notification, and we need to click on create event notification, and we need to give a name. So maybe we gave put object event. So this put object event, I don't give any prefix. No folder is needed. No suffix is needed. What I will select is all object create events. That means object created star. You can give a specific object create like the put object or post or copy or multipart. Right now we will select, to make it simple, all object create event. And I will select the Lambda function, and we can see that choose from your Lambda function, and I will click here, and we can select our parse event Lambda function and then save changes. So what we have done, so whenever there is any object that will be created in S3, it will trigger this Lambda function. Fine. So we go back to our S3 and we upload the object now. And from here we add files, and in desktop we have this sample1.json. We will upload it, and we will click upload, close. So my object is here. Now we see, did it trigger the Lambda? How to view that? We go to Lambda, and yes, we were in the right section, in monitor, in logs, maybe somewhere. No. So we can refresh this CloudWatch. Maybe it triggered and created this log group. Okay, now we see the error does not exist, that the log group does not exist. We can see that parse event is created, and the parse event log group is the Lambda function, and it created this event. What is the event? This is the event that we are interested in. So remember, we have printed the event. In our code, we have seen that we print the event. So this is our event. So we see here records. This is the event version, and the event source is AWS S3. And what is that? This is our region. This is our event version, and it contains also the bucket name. Here is the bucket name. The name of the bucket is this one, and also the key name. So the key contains in the object section, in the object key, and the name is sample1.json. This is fine. So we have seen that whenever we put the object in our S3 bucket, it triggered the Lambda and it created the event. Put object event triggered the Lambda, and Lambda in turn printed the event. Now what we have to do, we have to insert the particular event or the particular sample1.json, this data, into our DynamoDB. So for that we need one DynamoDB table. Now we create one DynamoDB table. So we are into our DynamoDB console, and let's create a table, and maybe we give it as event table name, and the partition key. Let's give the partition key same as here, fruit. So this is our partition key. That means this is our primary key. And I will not change anything apart from we will give a tag and then create table. That's it. So we create the table, and our DynamoDB table is being created. We go to DynamoDB again. Somehow it is not created, is it? Oh yeah, here it is. Okay, so our DynamoDB table is provisioned, the standard table, it is created. Now what we have to do, if we go to inside table, explore table items, right now there is nothing. Fine. Now what we can do, we can do some code inside our Lambda handler so that it can get the event, it can parse the event, it will show us what inside of this event, and it will insert into our DynamoDB table here. Great. What we will do is we will code something here in for our Lambda function. So we select the language, we know our Lambda is in Python, and then we give the code here. Okay, so this is our Lambda code. What we have done here in this Lambda is that we have imported JSON Boto3. Right now, Boto3 is required to create this S3 client and AST. Okay, now we see that this is the print event. The event that is coming from S3, we are just printing. And then we are taking the object key. So from the object key, we are taking from the event records, the first record, S3, object and key. So if we go to CloudWatch, we view this. We go to CloudWatch and we see that inside the event we have records, and after that this is the first record, and we have object and then key. So this is what we have done: records, first record, S3, object and key. And similarly the bucket name, instead of the object we have a property called bucket, and from that name we are taking the object and the bucket name. And we are just printing the bucket name is this one and object name is this one, to make it very simple. And then we are creating one S3 client, and that S3 client is under this region US East 1, and the response is what we will do with this S3 client. We will get the object. Which object? The object key that we will mention here, that we got from the event, and from the bucket that we got also from the event. So we go with this client and we will get the object to download it, and this is in my response. So if we need to read the response in a human readable format, we have to decode it. We have to decode it with this UTF-8 format. So we will decode it and we will print it in a human readable format. And after that, we will do a literal eval from AST. Why we will do it? To insert the data into DynamoDB. Right now we are just printing it, but eventually we will insert this particular data to our DynamoDB table. So I hope this is clear. This is very simple one to parse event from S3 bucket. What I will do, I will copy this part here, or maybe the entire one, and go to our Lambda, and I will just paste it. So that's it. This is very simple, and we will deploy this one. So our Lambda is deployed. What we need to do, we need to trigger the event again. So we will upload the sample.json file again. This is from my desktop and sample one. So I have fruit, apple, size large, color red. Fine, upload it. And we will select upload, close. So I hope as soon as it is uploaded, it will trigger the event. And as soon as it triggered the event, we see here, let's see if it created another log. Yeah, the second log is here, and we will open this one and we see this one. So this is our first event. This is our first print, and this is the event. And then this one is the bucket name. My bucket name is event source beyond the cloud. This is my bucket name, this one. And then we have object name sample1.json. This is the object name sample1.json. And then this is the human readable format of the file, fruit, apple, size large, color red. And this is the one that literal that we have done is what needed for DynamoDB insertion. So this is fine. So this is what we will insert now in our DynamoDB table. So everything is fine. What we need to do now, we need to create one DynamoDB client and we need to insert the data into DynamoDB. So what we can do, we can get rid of this print statement maybe. This is not needed. Only the bucket name and object name is fine. This part is fine. This is we need. And this also we don't need. And this also we don't need. What in turn we need is a DynamoDB client. So what we will do, we will create one DynamoDB client, and this DynamoDB client is Boto3 client, which is a resource of DynamoDB. This is fine. And then for this DynamoDB client, we have to create one table. So we will give table equals to this DynamoDB client dot table, and then we have to give our table name. So what is our table name? Our table name is event table. So this is my table, and then we have to give what item it should put. So we will give table dot put item. So this is how we put item into DynamoDB table, and we have to specify the item and what item it will put. It will put the file reader too. That is the literal evaluation is done. This is fine, and if everything is fine, it will return a success code of 200. So let's deploy this one. So I hope everything is fine, or I have done at least everything is okay. Now let's create the event one more time, or maybe what we can do here, give this also in a single quote. Okay, now let's create the event. Upload, add files. Fine. Go to CloudWatch. Let's see if any third event came in. Yes, third event came in, and we see that bucket name is there and the request is done. So that means there is no error. So let's go to our Amazon DynamoDB and let's verify if everything is fine or not. So we see when we ran this one, we see that one data has been inserted. What is the data? Is apple, red, large. If we click on this data, we see the value. The fruit is the apple, color is red, size is large. That means our sample.json, this has been parsed. So if we go here, if we have put the sample.json here in our S3 bucket, that in turn called the Lambda function, which parsed the data into human readable format. Also it parsed the data and inserted into DynamoDB table. This is fine. Now the last part, as soon as the data is inserted into DynamoDB table, it should trigger one Kinesis data stream. So let's create one Kinesis data stream first. We go back to our AWS console and we select Kinesis, yes, this one, and then Kinesis, we have already selected, it is already selected Kinesis data streams, and create Kinesis data streams, and this is give a name, maybe DynamoDB stream. This is fine. I will put it as on demand. Provision is not okay. On demand is fine because it will give me a huge write capacity and read capacity. If we select on demand, we see that we have to select the surd estimation, and one of the surd estimation is kind of 1 Mbps and 1000 records per second, and we have to give maybe 4 or 5 surds that is needed. So this is kind of, we have to imagine what kind of data we need, or we have to already estimate that how much data is coming into picture. This is provisioned when you do it manually. So let's everything do it on demand. So AWS will decide how much data is coming, and it will give me the surd that is needed to process the data or to keep the data. So let's not bother about it and put it on demand, and let's keep everything as it is and create the data streams. It will take some time. Now we see that our data stream, DynamoDB data stream is there. So it is kind of active. What we have to do, we have to configure this data stream to respond to an event coming from DynamoDB table. Which event? Any insert of data event from DynamoDB table. So we have to configure that into DynamoDB table, where whenever there is any insertion happens, it will call this Kinesis data stream. So let's go to DynamoDB table, and under DynamoDB table here, inside this table, we have this exports and streams. we can export the data into S3 or we can stream the data into Kinesis. So right now the status is off. Right now the Kinesis data stream is off. So we have to turn it on. So while doing it, turn it on, it will ask me the stream details, like in which stream you want to put the data stream event. I will select the stream that we have created, DynamoDB stream, and it created the retention period of the data is 24 hours. The number of consumers right now for the stream is 0 because we did not give any consumer to that. And the cert count by default, it will give me 4 certs. This is very fine for us. And then we will turn on the stream. It will take some time to turn on the Kinesis data stream. Now my Kinesis data stream is active. That means if we put something into our DynamoDB table, it will eventually trigger it to our Kinesis data stream here. How can we check that? Let's do one thing. For testing purpose, let's create one item from here. So maybe in fruit, we will give orange. And then we will create the item. As soon as we create the item, right now we have given orange, the color and size, we don't have to specify. This is the magic of DynamoDB table. I really love it for this purpose. So in every row, the column can be different. This is fine. As soon as we have created this event, this should trigger the Kinesis data stream. How to monitor this? There are two ways of monitoring. One is to go here in the monitoring, and we see here incoming data sum. This one we can monitor. We can view in matrix here, or what we can do, we can go to data viewer. This is the Kinesis data stream viewer, and we can select the cert. We have to search by cert because we don't know in which cert the data is inserted. So right now we give a timestamp like maybe today's date, and hour is 12. This is fine, and get the records. So we see that this cert does not hold the data. Maybe number 1, get the records. It also does not hold. 2, no. 3. Maybe search in cert 2, get records. Okay, next one. Next. We don't know the index actually, so we have to do it in this way. Sometimes if you are lucky, it will come here in the first page itself. Okay, eventually I found out in cert 0 in the first cert itself it inserted, and this is the data. And if I click on this one, I see this is the insert happened. Event name is insert, and the record format is application JSON, and table name, this is the table, DynamoDB table, it created the record, and the table name, it holds the event table which is of DynamoDB table, and this is the creation time, and then we have inserted fruit, and which is of orange. So this is fine. So this is how we can view the data. It also generate this JSON format. You can just copy the JSON format and also can view the data. Another way of viewing the data is in the CloudWatch matrix. You see in the CloudWatch matrix, when we open up the matrix here from Kinesis data stream, we go here to the monitoring, and from here we have opened up the incoming data sum count. And this is the matrix, and when we go to the matrix, this will open up this graphed view where we have the first one is incoming records limit. This one we don't need, maybe remove this one. We just need this part where we can see this is the first item that is generated, then this one third incoming records, and this is another incoming records is one that we have inserted the orange data. This is also one kind of graph format where you can view the data that is coming into our Kinesis data streams. This is fine. Now what we can do, we can trigger the whole process totally. So we have now the whole process defined, and we will trigger it by uploading one JSON file in our S3 bucket, and which will trigger the Lambda to DynamoDB, then to Kinesis datastream. So let's go to our S3 bucket. So first, maybe what we can do, we can just change this sample1.json. What we can give is maybe mango. This is fine, and the size is large and color is yellow. Yellow is more tasty. This is fine. My sample1.json is ready. What we can do here is to upload the sample1.json file into our source bucket. We will upload it. This is my file. I can see mango yellow. I will upload it. Let's go one by one. The upload is done. So whenever the upload is done, what it will do? It will trigger the Lambda function. Let's go to CloudWatch event our Lambda function, and let's see if it triggered a fourth one or not. This is my fourth event, and we can see that this is the event, that is sample1.json, that is triggered, and whenever it is triggered, it should insert the data into DynamoDB. We can go to our DynamoDB table and run the scan, and we see that the mango yellow large data is inserted. So whenever the DynamoDB table data insertion done, now it should trigger the data stream. Now let's go back to our Kinesis data stream and let's search for this data. Eventually I found the data into SARD3, and this is the data that came in where we have this float which is of string type mango, new image size of large, and this is the color is yellow, string type. This is the event that triggered, and we can see it in the JSON format as well. The large, this is the size, the fruit is mango, and color is yellow. And this one also we can see it in the CloudWatch log here. The incoming records, one incoming records came in. So whenever there is any SARD or any kind of message broker thing is there, so we have to search for each and every SARD, because we don't know in which round robin fashion the data is inserted into which SARD. So we have to go through each and every SARD and we have to view the records there. So this is how. So we have seen that as soon as a event is triggered into S3 bucket, it processes it via the Lambda function, entered into DynamoDB table, which in turn created a Kinesis data stream, and into Kinesis data stream we can view the data that it has from our data viewer and also from monitoring here. So I hope this video was informative for you and you liked the content of the video and get an idea about event-driven architecture. If you are new to this channel, kindly subscribe, like, and share your comment in the comment section. I will be back with another exciting video. Until then, goodbye and take care.